This is Euclid Book 10, proposition number 41, Lemma. That's right. Euclid Book 10, proposition number 41 had a lemma, and I never read it to you. So we're going to include it right here. And that the aforesaid irrational straight lines are divided only in one way into the straight lines of which they are the sum and which produce the types in question, we will now prove after premising the following lemma. Let the straight line AB be set out. Well, this is the line AB and it's been set out. Let the whole be cut into unequal parts at each of the points C and D. So we're going to cut the line here at C, we're going to cut the line there at D. And they're going to be unequal parts. Now we're going to say that line AC is longer than DB. Okay, now we're going to say that this line right here is longer than this line. I say the squares on ACCB are greater than the squares on ADDB. Okay. So first we're going to draw two squares. The first square is going to have the length of AC. So in other words, all four lines of that square are going to be the length of AC. And then all four sides of the other the other four sides of the other square are going to be the length of CB. Okay. Now we're going to draw two more squares. The first square is going to have all four sides the length of AD. The other square is going to have all four sides the length of DB. For let AB be bisected at E. So we're going to make E the bisector of this line right here. Then since AC is greater than DB, okay, let DC be subtracted from each. Okay, so now we're going to say that the length of AC is greater than the length of DB. Alright, so we're going to subtract the length of DC from AC. We're going to subtract this from this. And then we're going to subtract the length of DC from DB. We're going to subtract this from this. Therefore, the remainder AD is greater than the remainder CB. So now we're going to say that this here is greater than this here. But AE is equal to EB. So now we're going to say that this length here and this length here are equal. Therefore, DE is less than EC. So this length right here is not as large as this length right here. Okay. Therefore, the points C and D are not equidistant from the point at bisection. So the length from here to here is not the same as the length from here to here. And since the rectangle ACCB, okay, here we go. We got a rectangle now. Two sides are going to be the length of this, two sides the length of that. Alright, together with the square on EC, alright, now we're going to have to make a square. And all four sides of that square are going to be the length of EC. So now we have the area of a rectangle, and we have now added the area of a square. Those two areas combined are going to be the same as the square on EB. Now what's the square on EB? Well, we're going to have to take EB and we're going to have to draw a square out of it. All four sides are going to be the length of EB. And this is by Euclid Book 2, proposition number 5. And further, the rectangle ADDB. Okay, so now we have to make a rectangle. Two sides AD, two sides DB. Together with the square on DE. Now we're going to have to make a square. All four sides are going to be the length of DE. So, we add the area of the rectangle with the area of the square, and that area combined is going to be equal to the square on EB. Well, okay, so this is EB here. We're going to make a square out of it. Those areas are equal. Therefore, the rectangle ACCB together with the square on EC is equal to the rectangle ADDB together with the square on DE. And of these, the square on DE is less than the square on EC. Okay, so now we're going to say that the square on DE is less than the square on EC. Therefore, the remainder, the rectangle ACCB, is also less than the rectangle ADDB. So that twice the rectangle ACCB is also less than twice the rectangle ADDB. Therefore, also the remainder, the sum of the squares on ACCB, is greater than the sum of the squares on ADDB, so on and so forth. I hope you guys learned a lot from this. I will tell you more in a future video. Stay tuned.